everybody. Yesterday we have discussed the preparation of the nitric acid and reaction of the nitric acid with metal, which is more electropositive than the hydrogen. And today we are discussing the reaction with metal, which is less electropositive than the hydrogen. And first of all, we are discussing the reaction of the copper. So here we can see that, as in the case of the yesterday, today also we have so many the metal which is less electropositive than hydrogen. But here the importance is that the first reaction is first equation is very simple and it is similar in all the reaction. First one, nitric acid decompose to form H2O and NO plus oxygen. So oxygen here is oxygen in the in the atomic state. So this nascent oxygen react with copper and to form the copper oxide. Again the copper oxide react with the nitric acid and to form the copper nitrate. This is the reaction. So please remember the first reaction, decomposition of the nitric acid is common in every reaction. So please remember that equation, and only the difference is in the metal. Metal will react with the nascent oxygen and will form the corresponding oxide, and this corresponding oxide sometime react with nitric acid again and to form the corresponding nitrate. This is the equation. So as in the case of the copper, the silver and mercury react with and to form the corresponding nitrate. Now we are moving into the next reaction with concentrated nitric acid. So we discussed earlier is the reaction of the copper with the dilute nitric acid. But if we take the concentrated nitric acid, the product is the same, copper nitrate, but only the difference is the first equation, 2 nitric acid dissociate to form H2O and NO2 plus nascent oxygen. Whereas in the case of the dilute nitric acid, we will get NO, nitrogen monoxide. This is the only difference, and other are the same. The copper react with the nascent oxygen and we will get copper oxide, and again this copper oxide react with the nitric acid and we will get copper nitrate. So here only the difference is the nitrogen. NO2 is formed in the case of concentrated nitric acid, whereas NO, nitrogen monoxide, is formed in the dilute nitric acid. That is only difference. Now we are moving into action of the gold and platinum with aqua regia. The beaker which is shown in the right hand side is the dissolved gold in aqua regia. So we have to study the proportion of the aqua regia. Aqua regia is a mixture of the concentrated hydrochloric acid and concentrated nitric acid. It is in the ratio 1:3. 1 is the concentrated nitric acid and 3 is the concentrated hydrochloric acid. This composition is very important. We have to prepare the aqua regia in our laboratory while you are doing the inorganic analysis. Okay, so please note this composition 1:3. 1 is the nitric acid, concentrated nitric acid, and 3 is the concentrated hydrochloric acid. If you are mixing the solution, we will get the aqua regia. The aqua regia can dissolve the gold and platinum. And now we are moving into the slide shows the first beaker, that is which is in the left hand side is the gold, and the right hand side is the gold which is dissolved in aqua regia. Now we are moving into the equation of the reaction of the gold and platinum with aqua regia. So as we discussed earlier, then aqua regia is the mixture of the hydrochloric acid and nitric acid. So when we mix it together, we will get NOCl plus H2O and the chlorine which is in the atomic state. Okay. So this chlorine is react with gold. Gold is an is a pure metal and it will not react with the common reagent. But even then the gold react with chlorine and to form the uh, uh, chloroauric acid. And this chloroauric acid again react with nitric acid and um, so the overall reaction is gold plus aqua regia. We will get chloroauric acid NOCl plus water. Similarly, the equation is same in the case of platinum. Only the difference is the metal is different. So as in the case of the platinum, the same reaction will occur. Platinum react with aqua regia and we will get chloroplatinic acid. So this is the action of the gold and platinum with aqua regia. Now we are moving into the next reaction, action with non-metal and metalloid. So first of all, we have discussed the action with metal, which is more electropositive than hydrogen yesterday, and today we are discussed the action of the metal which is less electropositive than hydrogen, and now we are moving into the action of the nitric acid with non-metal and metalloid. So here also the first equation is common and the element is different, and we have to study the four different element non-metal, that is iodine, carbon, sulfur and phosphorus. So we are first moving into the reaction of the iodine. Here we can see that the nitric acid decomposed to form H2O and NO2. This equation is common in everywhere, but only the difference is the multiplied number, that is into 5. So here the nascent oxygen is produced and this nascent oxygen react with iodine and will get the iodic acid. Iodic acid is formed, HiO3 is formed. Now the same reaction, nitric acid react with carbon. The first equation is common, and in this reaction the oxygen, nascent oxygen react with carbon and to form the carbon dioxide. So first reaction is the nitric acid with iodine, we will get iodic acid. Second reaction of the carbon and nitric acid, we will get carbon dioxide. Next is the action of the nitric acid with sulfur. So in the sulfur, the first equation is common. Nitric acid decomposed to form H2O, NO2 and oxygen. This nascent oxygen react with the sulfur and water and to give the sulfuric acid. And similarly, as in the case of the sulfur, the nitric acid also react with the phosphorus and to form the phosphoric acid. So we have discussed the four different type of the non-metal and the nitric acid. Reaction of the non-metal and nitric acid. First one is the iodine react with nitric acid to form the iodic acid, and carbon react with nitric acid and to form the carbon dioxide. Sulfur and phosphorus react with the nitric acid and to form the corresponding acid, sulfuric acid and phosphoric acid respectively. Next is the reaction of the nitric acid with the metalloid, that is arsenic and antimony. So the nitric acid react with arsenic and we will get corresponding arsenic acid, that is H3AsO4. So the first reaction is common. Nitric acid is decomposed to form H2O plus NO2 plus oxygen, that is nascent oxygen is produced, and this nascent oxygen react with arsenic and combined with water and we will get the arsenic acid. Similarly, antimony react with the nascent oxygen and water, we will get the arsenic acid. Now we are moving into the reaction of the inorganic compounds with nitric acid. So first is the H2S. H2S, the first step is common. Nitric acid decomposed to form H2O, NO2 and nascent oxygen. This nascent oxygen react with H2S to form water and sulfur. And this is the reaction of the H2S with concentrated nitric acid. If you are using the dilute nitric acid, we will get the same product, that is H2S react with oxygen, nascent oxygen, and we will get the sulfur and the water. And next is the reaction of the concentrated nitric acid with sulfur dioxide, and we will get the first equation is common. HNO3 gives H2O plus 2NO2 plus oxygen, nascent oxygen. This nascent oxygen react with the sulfur dioxide and water to form the sulfuric acid. And next is the reaction of the sulfur dioxide with dilute nitric acid. We will get the same product, sulfuric acid. And next one is the reaction of the nitric acid with ferrous sulfate. Ferrous sulfate, the oxidation state of iron in which is the plus 2. And if we react with the nitric acid, the first equation is common. Nitric acid decomposed to form H2O plus 2NO2 plus oxygen. So the produced nascent oxygen is react with iron sulfate and to form this the ferric salt. That means the oxidation state of the iron is changed from plus 2 to plus 3, and we will get the same result in the case of the dilute nitric acid. A ferrous is converted into the ferric salt. Next one is the action of the nitric acid with organic compound. So the nitric acid, first reaction is the nitric acid oxidizes sucrose to form the oxalic acid. This is the reaction. Next is the action of the nitric acid with benzene. We will obtain the nitrobenzene. So the reactions, the chemical reaction of the nitric acid is over. The nitric acid react with most of the compound. First is the reaction of the nitric acid with metal, which is more electropositive than that of hydrogen. We have discussed the magnesium, zinc, lead, etc. And next one is the reaction of the nitric acid with metal, which is less electropositive than hydrogen. We have discussed the copper and gold and mercury. Then reaction of the nitric acid with gold and platinum with aqua regia. And next one is action of the nitric acid with non-metal and metalloid. We have discussed the non-metal as iodine and sulfur, phosphorus, carbon, and metalloid as arsenic and antimony. Similarly, we have discussed the reaction of the nitric acid with some of the inorganic compound, thus H2S, sulfur dioxide, and iron compound. And next is the reaction of the nitric acid with the organic compound, sucrose and benzene. So we can see that the most of the elements, the most of the nitric acid react with the majority of the non-reactive compounds or metals, the gold, platinum, and benzene. Also in organic chemistry we are used as a solvent, but even then it react with the nitric acid. Thank you.